Hello. Today I would like to talk about ESP32 device. This will be a new series about this device, so let's see what we can learn. This is ESP32 WROOM 32 with 38 pins. And you can read about it here, and you can see that it has a Wi-Fi, it has Bluetooth, it has a 520 kilobytes of RAM, and also 4 megabytes of flash. It has UART I2C SPI, so it has also ADC in DAC, and this USB UART converter allows to just program this device, and this is the way it is working here. So I will show you how we can program this device, and I'm talking about exactly the device I bought last time. So exactly this one. As you can see, I'm using exactly this device, and yeah, so we can work with it, and I will put it here like that, and we can see I have a ESP32S model node MCU, so exactly the one I presented on the website. So this is something that I'm going to use. Okay, fantastic. So let's go back here, and I created a tutorial, so I will follow step by step to guide you through this entire process. First of all, what you have to do, you have to, I will make it even bigger, you have to understand that not every USB cable is working. So you need a USB to micro USB or USB-C cable, depending on the port type in your ESP32. And I am using a USB to micro USB cable and had to test some of them because not every USB to micro USB cable was working correctly. And after that, when I figured out which cable is working, I was able to make it work. I was able to program this device. And drivers. Most modern operating systems automatically recognize ESP32, but you may need to install CP210 USB to UART bridge VCP drivers. If you will have to do this, just you can look for this in the internet. Okay, connection. So when you will connect the USB to just ESP32 device, and you will be able to see that the just the flash is flashing, and then the LED is flashing, the red one. And I will show you this, and it will mean that the device is connected properly to the computer, right? And here is an option checking the connection. So what you exactly need to do. So on Windows, on Mac, on Linux, and I will show you how we can do this in Linux. And so you have to just list dev tty device and with star to make it work. So let's open the command line quickly and let's do this. Currently the device is not connected, so ls just dev tty and a star will show you the list of the device here, right? So now I will connect our device to the USB, and you will be able to see that in fact it is working just like that. So give me a second. And now my device is connected. So I will show you this in a moment, that it is in fact working, and it's visible here. So you can see dev tty USB 0 is just connected, right? Fantastic. So we can try to make it work, and we will find out, is it working as expected? Or maybe I will, yep, the red flash is flashing, the red LED, right? And you can see it here. So it means the device is connected. Fantastic. And when you know the name TTY USB, in my case, we can follow the steps. So I will minimize this window now, and we can perform a backup. Before we will proceed with the installation with anything in the ESP32, it is good to have a backup to perform a backup of a firmware of the device, and after that, when everything will be fine, then you can proceed. Because when something will happen, and for example, you will try to upload the code to the ESP32 and it will fail for some kind of reason. Sometimes it happens. Then, well, you can just quickly restore the backup. So I explained how to locate the device, how to find a name, and then we can use the ESP tool to make a backup, and also you can see we can easily revert the changes. I mean, we can easily upload the backup to this device. So here is the backup command. I will show you the small difference between command. The first one is able to read the flash, and the second is able to write the content, write the flash on the device. So let's go back to the beginning of this tutorial. So backup. To perform a backup, we will need an ESP tool, but to install this ESP tool in Debian12, because I'm using this system currently, we will have to follow these steps, because without them, we will not be able to just install the ESP tool, right? So this is the first thing that you need to understand. I will clear the screen now. I will install the ESP sudo apt install Python 3 PIP, Python 3.11 virtual environment, Python 3 WXGTK4 version. This is the graphical library, and also the Python 3 full. So I will execute it now, and it will install the necessary packages. Okay, fantastic. Now we need to do something like this, and I will display it. We need to have a ESP tool. So I will get rid of this because I was f backup and ESP tool directory like that, and yep, they are gone, and there is no backup directory, and I have only backup ESP32, and I will leave this one that was previously and installed. And now I need to create a mkdir ESP tool, right? So I need to have a directory to just use Python inside of it. So you can see mkdir ESP tool. Then we need to have a Python tree. So we are creating a virtual environment inside this. So I will go into ESP tool, and inside of it I will create a virtual environment. And this is something that is really needed, because then we can proceed with the installation here. So we will use this one to just quickly execute, and we will install the ESP tool using PIP. And that's it. You can see it's ready. So we can list the content, and we will go into the binary directory, and we'll list it, and we can see we have a ESP tool here, and we can use it just like that. We have ESP tool.py. This is our, and I will cut it even, cut ESP tool.py. So this is our script in Python that we can use. It's quite small to perform a backup of our firmware on the device. And fantastic. So now when the device is connected via USB, and I presented it, then we can scroll down, and we can create a backup directory. But before I will proceed, $user, so we need to create this variable. So I will just do this user, and in my case, equals Adrian, because cd just like that, and ID, and print working directory, home Adrian. I'm using user Adrian located in home and Adrian. Fantastic. So mkdir and something like this, and then we have to create a home user backup. So I will just copy this path and I will quickly put it here, and here we go, and ls backup, here it is, cd backup. Fantastic, and print working directory. I'm already there. Okay, so the next step is to use a full path, this one, to perform a backup, and I will show you this in a moment. Control C. Let's go back quickly here, and I will paste it here. Sudo full path to Python 3.11 version, then full path to ESP32.py file that is required to perform a backup, then -- port, so we have to define our device. In our case it's TTY USB 0, then baud rate 115200, then -- before default _ reset, -- after hard _ reset, and now you can see read _ flash. So this command, it says I'm going to read the content of the flash on this device, and I will save it to a file backup flash content bin. Hit enter, and now it is trying to detect the chip type, it's trying to connect, and you can see there is some kind of warning. So sometimes it happens that it doesn't work. If it will stop, you can just hit Ctrl C on your keyboard, or yeah, like that, and clear the screen and rerun the command once again. And now you can see there is no error, and it says that the crystal is now set to 40 megahertz. So previously there was an error, and sometimes it happens that the first connection doesn't work. So you just need to connect it this way. When something like this will happen, do not worry, make a backup once again. So you can see it is done. So we have a backup, and we can go to the directory like that and backup. There we go, and we can delete the content, and now we have a file flash content bin, and this is our backup of our firmware of ESP32, right? So we can use it to restore it, but I'm not going to present it. Just I will show you that there is a option to make it work. So you have to make the device writeable. So thanks this you can write the content, the file onto the ESP32, and the difference is here because we have something like write _ flash. So this thing will write the content, the binary file, onto the ESP32, and this way you can restore it on your device. Fantastic. So that's it. And remember that this copy contains everything in the flash memory, including the bootloader, partitions, and application. So yeah, that is why we would like to have a clean, just clean firmware, clean bootloader, clean without any application. So thanks this we can achieve this goal. So before you will proceed, before you will upload anything on your device, make a backup. Then we need to install the Arduino. So I will use Nala instead apt-get, just because it is a much more convenient and faster tool. So I will do this, and sudo Nala just update, sorry, and like that, and it will perform a check. And now it should work. Everything should be up to date. There shouldn't be any update available, and I will be able to proceed with the installation. Okay, fantastic. All is up to date. So Now instead of an update, install the Arduino and -y. So instead now I can use apt or apt-get command to install the Arduino. Fantastic. So it is installed and there is next step to be done. So I will try to show you this one, and you need to add this group to a currently logged in user. So I will just follow this sudo user mode -iag, or we can do this way. It will also work, and ad Adrian now, and you can see I have this dial out group here, so it is added to my account. Fantastic. Why we are doing it? Just because we want to run Arduino without root permissions. Okay, so then also make sure that you can write to the device. So I will just copy it like that and put it like that, and will perform. And now lslah and dev tty usb 0, and that's it. Fantastic. And you can see now it is owned by a root and dial out group. Okay, good. Now after executing this command, it will be necessary to restart the system or log out and log in back. I don't have to do this anymore just because I already did it, and yeah, and it is working. So now I will just run Arduino. And here we go. I will open it. Okay, I will even pin it here. So now I will try to make it a little bit bigger, and you can see here is the window where you can put the code. But before we will do this, before we will proceed, we need to go to file preferences, and we need to perform some kind of steps. So first of all, we need to add this URL into the field additional boards manager URL. So here we go, and the file and the preferences, and here is the field, and just do this and this. And now the next step is to just go to tools board and boards manager, and there you need to search for ESP32 and install ESP32 by Operative System. So we will do this. So let's do this. Tools, something like this, and where's the port manager? Here. So we have to click it here, type ESP32 here, click enter, and select this one and just click install. So we can see it is installed, and I will close it now. It took a while, so yeah. Then we need to go to Tools board ESP32 and look for AI Tinker ESP32 come from the Arduino IDE menus. Actually, why? Just because for this device we need to exactly choose the proper model. So I will try to look for this thing here. Okay, let's try to open the tools. Something like ESP32, just like that. And we have this, and we are looking for ESP AI Tinker. So I will try to scroll down. Okay, so it is located here. So we have to choose this one. And when it is selected properly, we need to follow the step in the tutorial. So select the appropriate model, select the correct port, and select proper frequency. So we will look for this here, and then we need to look for this. So in tools, we have something like the board, and we have this frequency. So I will change it to 40 megahertz, and after that, when I will scroll down here and I will select the proper port. And then also it is good to select the proper debug level. So I will choose the verbose because I like to know what is going on. And okay, this is the step number 4. Now we have to test the connection, right? So we need to open an example sketch. So I will try to upload the Wi-Fi scan, and I will click File Examples Wi-Fi and Wi-Fi scan, and I will try to upload this program into ESP32 device. So let's try to do this, and File, and then we have something like examples, and we can scroll down and we have a Wi-Fi here, and then from the Wi-Fi we need to choose something like Wi-Fi scan. Okay, and I will close this one because I don't need it. I will maximize this one so we can see we have a code, and that consists of this thing. Okay, and now the next thing is, you can see it is able to detect open, WEP, WPA, WPA2, PA2 and PA, right, and EAP, WPA3, WPA2 plus PA, WPA3, and WAPI, and some kind of unknown security. Okay, fantastic. So now I can try to just, first of all, check all the settings. So first of all, check the port. Here it is, the verbose. Here it is correctly, and this one is correct, this one is correct, and this one is correct. All of it is correct. Fantastic. So we can now just try to upload the code here, and I will just move it like this. And now here in the top right corner of this black window, where you can see the progress, and we have some kind of warning that you can see here. And basically this is it. So you observe the process, and you can see it's quite quick because the progress bar is moving, right? So you just need to wait a little bit in this situation, and you should see the progress also in this window, because it should display some information in this black window, and you will see that the code is uploaded, and you will be able to make it work. So you can see our Hiving build core now, and connecting, and it is writing the code onto ESP32. So it's uploading the binary file actually after the compilation process, right? So it compiles the code, and now it is writing it, and fantastic, it is done. So the code is uploaded to the device. And now if you're curious what you have to do, you just click on Tools. Then there is something like a serial monitor here. So you have to open it, and all you have to do, okay, I will just make it a little bit smaller. Here you have something like a baud rate. So we will select the correct baud rate, this one, 115200, and now you should see the status, the progress. So it is scanning the entire network around this ESP32 device, and it's trying to discover the SSID. Of course, this code is able to discover only those SSID that are not hidden. There are programs that are able to discover hidden SSID, so hiding SSID, it's hard to say is that a good idea. You can do this, it can increase a little bit the security, but the most important thing is the encryption. So encryption should be set as high as it is possible. So WPA2 and WPA3 is something that I can recommend. So I really recommend to set a proper security on your router, just because if there is an open web connection, right, there's an open network, so you can connect easily to this network and you will be safe. So channel, so if you're curious, it says on which channel the network is working, and then also the strength of the signal, right? RSI column says that the strength of the signal in decibels. So you can find out, actually can guess how far this router is located, how far from the ESP32, right? So we can see the closest network is this one, IoT, and then the next one are just located somewhere over there. And this is the way we can work with the ESP32. Actually, you can write the code and you can upload it to your device. Of course, there are examples and you can see a lot of, so you can test it if you want to. But this is basically the way we can work with this device. I hope you enjoyed this video, so have a nice day or night. Take care, bye bye.